Thank you so much, Mr. Hamish. Thank you. And wish you all the best with your hard work. And I just want to say we appreciate you. And I have achieved like 93%. Sanbonani. This is Emma Onokula Wamkiz Bongo. I live in Devon in KwaZulu-Natal, and I was born in KwaHlabisa in KwaZulu-Natal.
Hello, how you doing? My name is Hamish. Let's get started. So before we get started, if you're new here, please, I appreciate if you can go to my website, and I appreciate any donation, because with all your donations that you did in the past, or anybody have donated me, that's what sustained this project. So I appreciate for everything you did for me. Let's get started, man. So now we have a question right here. So this question here, you see, you have two blocks. I'll explain to you overall. So this is the first block, 2 kilograms, 30 kilograms, and this is inclination like a mountain. Let's say somebody's pulling. Let's say this is on the floor. This is a mountain, let's say. So you're pulling 2 blocks. But this box, it could be box or whatever you have, is connected by inextensible string or massless string. Means this string does not have no mass. It doesn't have any weight. Inextensible string. Or you can say massless string. For the most case, they say massless string or rope. You see? So somebody's pulling. But now the funny things here, they don't just pull it like straight. They just kind of put at a certain angle like this. But anyhow, even if you put in a certain angle, it's going to be pulling. It's going to be coming this way. So we're going to have to resolve this vector, because we know this is the force which is going to be, because it has to be in the same line. So we're going to have to turn it. Let me show you now how we can turn. Because now, look, this force here, because they pull these 2 blocks in a certain angle here. So we know for facts the force which is going to be pulling these 2 blocks is going to be this force here. Means the component of the actual force. Let's call this force. So this angle theta, this is a force. But remember, let me show you this before you get started, because you're gonna need this for you to solve this question. Okay? For example, if I have a triangle like this, this is a normal triangle, right angle triangle. This is for the right angle triangle. Let's say this is anything. Let's say force, 7 force. Now let's say find here and here. But remember, anything which is vertical, or look. You see this one? Angle. The angle is always between hypotenuse and adjacent for most case. See your angle? So the angle is between what? This is always between hypotenuse and adjacent. Whenever you have an angle, right angle triangle. So what does that mean? This my hypotenuse adjacent, this is going to be opposite. Opposite is something which is vertical. So now, if you want to get adjacent, just remember this. Adjacent is always cosine. So I'm going to say cosine of angle, and then make sure you multiply by the hypotenuse. Simple as that. For the opposite is sine. So I'm going to say sine of my angle, and then you must multiply by the hypotenuse. So remember that, like, face, I have to identify what's my angle, and then I know adjacent is cos and opposite is sine. Now, so for this one here, look, this is my angle. So whenever there's an angle, look at this triangle. Whenever there's an angle is always between hypotenuse and adjacent. Oh, but how do we get adjacent? Because I need the one which is this. This is the component of a force which is pulling all these 2 blocks, because it must be the same line. But for some reason, this person was pulling that way, so we have to resolve this vector. So how are we going to say that? So I'm going to say, okay, so this horizontal force, we know is adjacent. Adjacent meaning cosine. So I'm going to say cosine of my angle times by hypotenuse, F for this case. So even here I'm going to do the same thing. You see, this is hypotenuse and this is my angle. So this is adjacent, because angle is always between hypotenuse and adjacent. So how am I going to get adjacent? Adjacent equal to 40 cos of 25. Now let's go. So that's the first step. You know what I'm saying? Okay. Now let's go to the question now. I'll just warm up a little bit. Okay. Question. In the question they say state Newton's second law in words. Easy, man. Newton's second law in words. Okay, let me explain to you quick, so that next time you won't have a problem with this. Okay, so now Newton's second law of motion, I'll show you now how to extract it, just in case, let's say, because it's not good to memorize all the time. Look, me personally, let's say I forgot. I'm in your position, then I'm a student, then I forgot. I'll say force net equal to mass. We know force net equal to mass times acceleration. Okay, so now we're gonna say and then make acceleration the subject. So I'm going to divide it by m, and I will divide by m, and this cancel. So my acceleration equal to force net over mass. Now look how I'm going to construct now. I'm going to say now acceleration, see this acceleration, is directly proportional to the net force, and the same acceleration is inversely, because see this is direct, this is inversely. So acceleration is directly proportional to the force. Force net means net force. So acceleration is directly proportional to the net force. In the same acceleration, you can say, you can say it also, you can say acceleration also, or you can say acceleration, or you can say it also, or whatever. Acceleration is inversely. She's inversely proportional to the mass. Okay, so we're done with Newton's second law of motion. So this is Newton's second law of motion. Second law of motion. So what does that mean? Means whenever a net force increases, an object is going to accelerate quicker. You know what I'm saying? Whenever, for example, let me give you a good example. Let's say me and you pull each other. Let's say you have, like, say, a rope. I'm here, and you're here. So we got a rope. Or arm wrestling. Let's do arm wrestling. So at first you had 4 Newton and I had 4 Newton. So what happened? We're not going to have a net force, because net force means I have to look where this object means different between these two forces. That's a net force. So like if you have the same force, means no one is going to win. So you decided to say, you know, I'm tired, I'm going to add more power, more force. Okay, you decided to add another 5 Newton. So what happened? Means you're going to have 9 Newton, I will have 4. So who's going to win? You're going to win, because you're going to break arm wrestling me and then I'll lose. So what is the net force? The net force is this extra force that you have brought up. Means if you want to get force net, for this case, I'll say, okay, I have to look where the direction of the force. You have more force than I. Means you're going to pull me more. So I will say net force, I have to look at the direction. The direction of this object now of 2 arm is going to be going toward you, because you're going to be winning. So we're going to say 9 Newton minus my 4 Newton. And this is going to give us 5 what? Newton toward you. You know what I'm saying? So means this object is going to accelerate. Means our arm wrestling, you're going to be accelerating me. Means you're going to move me. Alright. So what do we see? If you increase, let's say, 10 Newton, let's not 5 now, 10 Newton, what happened? You're going to have 14 Newton. So what happened? Means your force is so big, means you're going to accelerate me so quick, like quick. So means you're going to have 14 Newton minus my 4, which is going to give you 10 Newton. Means, so we see, so net force is 10 Newton. The more the net force increase, means an object is going to accelerate quicker. Like let's say we push the car. If I push the car alone, let's say small car, it's going to move slow. But if you come and help me, then we push, means the resultant force of the car, because the car is going to resist, like let's say this is the car. And then we push this car. Me and you push. So what happened? At first I was alone, me 1. So it was moving slow. But if you come also, then we push, means our force is going to be bigger. Let's say 80 Newton, I'm just saying. But I remember in a tire there's a resultant force, which is opposing. So if you want to get net force, let's say it's 2 Newton. If you want to get net force, means you must take 80 minus 2, because this friction force is moving opposite direction and this we pushing the car. So you're going to take 80 Newton minus 2 Newton. It's going to be 70, 80. So it means whenever the net force increase, means this car is going to accelerate quicker. So that's why we say a net force is direct proportion to the acceleration. Means the more something accelerates, means there's a more net force. When something accelerates slow, means the net force here is slow, and you know net force right now. But acceleration is inverse proportion to the mass. What does that mean? If something too heavy is going to accelerate slow. You know what I'm saying? Means the bigger the mass, the acceleration is going to be slow, because something too heavy is going to go accelerate slow. But if something too light, means if something the mass is small, it's going to accelerate bigger. In other way. Okay, so now we have already defined Newton's second law of motion. Now let's go to the question. So the question here, they say find acceleration. Want to get what acceleration? And let's read the question again. Okay, so the question here, they say everything they say here is what's representing this diagram here. Okay, let me just erase this stuff here so we can have a space quick. Okay, cool. Now let's go. So now they say here black P of mass 2 kg is connected to black Q. Or P and Q are connected. See, just like how we see. And they say block Q of mass 3 kg. This and this with what? With light inextensible string. Oh, so this string is very, very light. Now, just like everything they say here, there's an angle 30, P move on a rough section AB. Oh, so this P is going to move on rough section AB. So this section here is very rough, means there is a friction force in other way, because very, very rough. So the friction force here is going to be more harder or more rougher compared to here. This is more smoother. You see what I'm saying? Now what do we want? Okay, the first part they say draw level free body diagram of block P. Okay, free body diagram of block P. So first and foremost, we know we have to draw the force diagram. You know, I say this all the time. The best way to get a free body diagram, draw your own force diagram. What is a force diagram? I'll show you now. Look, let me start with this one. If this object is here, so we know right all the force. We know it is going to act force of gravity, which is vertical down. Vertical down. Okay, so this is going to call face off force of gravity, but for Q. So let's call face off gravity. This is for Q. Let's say force Q. Let's say force Q. Right. Let's write like that, but it's not important. We know FQ of gravity means force of gravity, and because of Q, let's say FQ gravity. Now, we know we're going to have a normal. Where the normal force come? Normal force come from the surface. See, because normal force is always perpendicular toward the object. So you go to your surface. This is my surface here, and it's always perpendicular. Means this is always like this to the object. Means you see, make angle 90 perpendicular. See what I'm saying? So this is going to call what? Force of normal. Let's call force Q normal. I'm just coming up with that Q just to show the difference, because remember we have another object. So then after that, try to prolong it. So this is going to be like this. Is a component of this vector. This is component of this vector. Look. Let me ask something. If somebody have this, let's say, and this is my angle. So where's my adjacent? I know if this is the angle, we know this hypotenuse, it doesn't matter how they turn it. And whenever there's a hypotenuse, I know this is going to be my adjacent. The hypotenuse also, when I see the angle, I know it must be hypotenuse and adjacent, or this adjacent, so opposite is going to be here. They just turn this triangle. So So this is going to be the opposite. See? So same here. This angle is going to be the same with this angle 30 from the similarity, mathematics. Okay, so now mathematics, now we go. So this is going to be adjacent because this is going to be hypotenuse, this is adjacent. Okay, and then write like that, and then we connect here. This is going to be opposite. But when you draw your opposite, remember, this line it must be parallel with this. Parallel means it must be, don't write like this. If you draw like this, you're wrong. If you draw like wrong, or like this is wrong. It must be parallel with this inclination. So it's going to go like this. See what I'm saying? So now you go, look. So this is hypotenuse, this is adjacent. Adjacent is cos. Oh, so I'm going to say cos of my angle, which is 30, and always multiplied by the hypotenuse. Hypotenuse is FG, but I say Q because of the letter. So FG. FG. So I'll say what? This is going to be FG. Okay, so this is going to be opposite here. Opposite is sine. So say sine of my angle and then multiply by the hypotenuse, which is FG. Okay, so this is the first diagram of object Q. Now let's go first diagram of object P. We do the same game, guys. Now let's go. So this is going to be force of gravity, vertical down, it must be vertical. So force of PQ. P, you know, it must be FG. But I'm just put this P to say it's for this object, okay? So now, you go normal. Normal means from this surface, you must be making angle 90. Like this surface here, this must come from this surface toward the object. Guys, you must be very careful. Don't draw like this, you must make angle 90 there. Now we go, so let's prolong. Now when you draw, this must be perpendicular. This and this must be inclination, this must be perpendicular. Excuse me, my apologies guys. Parallel. Parallel. Okay, so we know this is a component of this F of gravity of object P. Now, so this angle must be equal to this, always. From similarity, this angle 10. So this is adjacent. Adjacent meaning cos. So say cos of our angle, which is 30 for this case, times by FG. Same here, this is opposite, which is going to be sine of 30 and then FG. Now, so this is the first diagram, but remember, you have to know where this object is going. This object is being pulled up there. So if it's pulled up there, if I start, okay, when you do your first diagram, it's not good to consider double things because it's going to confuse, or two things, or three. Let me assume I hide this, like hide it. So I'm only dealing with this. So if I'm dealing with this, now assume like you don't have this. So if this stuff is moving that way, what is the force opposing? Oh, we know here we're going to have what? Friction force. And also remember, just don't want to put this, just assume like you don't have. If this object, because you know this object is moving up, so this tension is going to be opposing tension, because in a string you're going to have a tension. So this tension is going to be positive. Oh, so this is all the force we have for object 1. For P. Now let's go for Q. If this tension faces this way, this tension here is going to be facing each other, because tension, they must cancel one another. So this tension is going to be facing this way. So hide it. Assume like you don't have it. You know what I'm saying? Now, so what is moving up? What is force causing this object P to move up is tension, because tension, they always face one another, or they cancel one another. How are they going to cancel? They have to face one another. Now let's come here. So we're going to have also friction force here. So friction force, because this object is moving that way, so friction force opposing. So there's a friction force here, but the friction force of here is going to be bigger compared to here. You know why? Because this is more rough. So when something rough, let's say you got your car and then you always drive the mountain on a rough road or bed road, meaning the tire is going to get finished because the friction force is bigger. So we look like this object is moving up. Okay, so something opposed what? Friction force. Force of friction. But let's call this F, friction K, and this let's say for P, and this is for Q. Let's go something like that. Now, what do I want in the question? Let's say, draw a free body diagram for P. Okay, me now, let me challenge you. I need free body diagram for both P and Q. Okay, cool. Let's start for Q. So this is a force diagram. So for free body diagram, is easy. Write the center of an object. Now we say for Q, right? For fun, I'm just do for fun Q. But an exam, in that question, that's for P. So I'm gonna write my dot over here. Means the center of here. Okay, which is actual force? Write the actual force, guys. Oh, I forgot something. Excuse me. You see here, you need to show this force because how does it move up? Which force make it move up? 40 Newton. But remember, you must draw this parallel force. So we need this force here. So this is cos because if you look at this triangle here, it's like hypotenuse and adjacent. So adjacent is cos. Cos of 25 degree times hypotenuse, which is 40 Newton. 40 Newton, cos of 25. You don't have to, I think you say 40 Newton, we can just say 40, but we know it's 40 Newton. Now, so now, free body diagram of Q means draw the actual force. So this is Q, means this dot here, the center of Q. Which force is actual? Force of normal. Don't draw this component, eh? I say all the time, this component, leave them like this and this. The rate, even this is a component, so don't take it. So our first force is going to be force of normal. Even direction must be the same, force of normal. Another force, oh, we have this, which is what? Tension. Another force, force of kinetic. So you can draw two here. Force of kinetic. Another force, force of gravity. So you draw the same direction. Did this one straight down? You draw down. Okay, another force. This force. Don't draw the component. That's why this and this are not on the right. Even this and that are not on the right. So draw that. Which is 40 Newton. So this is free body diagram of Q. Then when you finish, you can just say Fn is the normal force. T, tension. Okay, this is just a force for a Newton which is given. Okay, now we go Fk, friction force, kinetic friction force. Kinetic friction force. And then Fg, force of gravity. Force of gravity. You know what I'm saying? So, you understand? So that's how you draw free body diagram. But these two, leave them. Even this is a component, leave them. Now, let's go for P, the question that they ask us. So, free body diagram of P, let me see how if you can try. How would you give me the force diagram of P? Okay, cool. So we will say now free body diagram of P. Okay, so center. Okay, we have a force of normal. So force normal of P. Let's go. Okay, so it's gonna be force of normal. Okay, another force, force of gravity. Another force, force of kinetic friction. Okay, and then we have a tension there. Those are the forces. This one we don't want to write because they're components. So we're done. Now let's go for the second question. So the second question, let me see what they want. They say, calculate the magnitude of acceleration of block P. Okay, so the one acceleration of block P when it's moved from A to B. So whenever they ask for acceleration and tension for these two types of object, split your diagram into two parts. So how are you going to do it? Look, the one acceleration of what? Of V6, 2 kilogram, right? But remember, the way how this object is going to accelerate is going to be the same because they're tied together. So if I'm going to pull this, which force is going to pull? This is going to be the pulling force. Because this one is a pulling force, but it must be like in the horizontal. So this is the one which is going to be like making move this way. Okay, cool. So now they want acceleration of this, but the acceleration of here is going to be same with it because they're all going to move, they're tied together, so they're going to move with the same acceleration. So what I'm going to do, I'm going to start either of that, this or that. Okay, but this question type of simultaneously question. Let me start for block 2. For block, for which block? Block P. So now let's look where this object is going. It's going what? Up. I say it again. Don't do them together. One, split. So now hide like this. Like everything for this object, hide it. So this is what you have. So which force make this object moving up? Is tension. Is tension, because look at the other tension. Oh, so tension. So we're going to say here, from Newton's second law of motion, force net equal to mass. What is F net? I have to look direction. So direction, height of object 2 kilograms. What is that making moving up is tension, because look at the arrow. Arrows are moving up. So tension minus the sum of anything which is opposing. What is opposing? Force of friction or kinetic plus any other force opposing. Oh, this one. This force is parallel with this. Is parallel with this. So Fg sine of theta equal to mass times acceleration. Do you have a mass? Yes, 2 kilograms. Do you have acceleration? No. That's what we're looking for. So let's simplify a little bit here. So we say tension minus kinetic friction force of which we have, which is average constant friction force of block P or block P. Okay, so we have average constant of 2.5. So we have 2.5 here plus, and this Fg means mass times gravitation. Mass of this is 2 kilograms times gravitational is 9.8. Sine of 30 is a half. We can say 0.5 equal to 2a. So now you take that and you plug in a calculator here, just a second, and this is going to give us excuse me, just a second, is going to give us 12.3. Yeah, it's going to give us 12.3. So these two, so we're going to say tension minus all this together is going to give us what? 12.3 equal to 2a. So you see, you kind of stuck here. Let's call this first equation, because you don't know tension, you don't know acceleration. So let's stop there, and then now, if you stop there now, do for the object 2, and then we're going to solve simultaneously. So now, hide this, and now we come here because you couldn't get acceleration. So you hide it here. Okay? Now let's go. So we do the same game. So if I'm hiding here, where you have to look where this object is going. Is moving, is pulling what? Up. So which force is causing moving up? This one. Even though we know it's 40, but I take this one, which is component of this force, which is 40 cos of 25. So we'll say what? For object to object Q now. So we're going to say what? 40 cos minus. Okay. Which force opposing? This Fk. So we add all the Fk kinetic of here. You know what I'm saying? And then tension, because look how they move. This move this way, tension move this way. And another one, this one, Fg, because Fg sine of theta. Fg sine of theta. And this equal to Ma, because F net equal to mass. So Ma for this case, M is 3, and acceleration we don't know. So we can plug in all this stuff, we have it here. Okay. So now we say okay, so this one we can plug, so this is 40 cos of 25 minus. Okay, what do we minus? Oh, sorry. According to the equation, this is smooth. So if this is smooth, means we don't have any friction force. Let me go to the question quick. Okay, object Q has a in light look at planet. Okay, so object Q, it does not have any friction. Because they say the frictionless surface. So a block Q is in a frictionless surface. Means Fk here is going to be equal to 0 because this is a frictionless surface. So I was not supposed to write it. So this will be like a 0 and the plus because the frictionless surface. Tension, do you have a tension? No, we don't know. We plus Fg sine 30. What is Fg? Mass and gravity and then sine of 30. Our mass for this case is 3 times gravity 9.8 sine of 30 equal to a half. You know what I'm saying? This and this constant, so you can simplify. You can say 3 times 9.80 times 0.5. Okay, equal to 3a. Okay, now so let's simplify. So, excuse me guys, let me drink a little bit of water. Okay. So now, in the matter of simplification now, this is going to give us 14.7. These two is going to give us 14.7, and remember, this is going to be like a 0. 0 plus t is going to be just a 0. So put it in, it's going to be minus t. And put it in here, it's going to give us minus 14.7 because this is going to be 14.7, but when we put it, it's going to be negative. Go to 3a, and this is going to be 40 cos of 25. 30 cos of 25 is going to give us 36.25. 36.25. 30, these two, 36.25. You know what I'm saying? So now I can put together this and that together. So if you put it together, it's gonna give you 21.55. This and this because 36 comes minus 14, 36 minus 14, 21.55 minus tension equal to 3a. Okay? Let's call this one second equation. So I have to solve question 1 and question 2 simultaneously to get the value of a and t. You know what I'm saying? Let's solve this and that simultaneous to get the value of a and t. So I could have taken this. You see, this is t equal to that. Look, this one, take 1. So I can make t subject because I'll take it over. So t equal, you see this one, I'll take over, it's going to be equal to 2a plus, because this one go over here is going to become plus. Plus what? 12.3. So this stuff here, we know the value of t, but in terms of a, I'll take this t and place here, which 22a plus 13. So 21.55 minus, instead of t, we say 2a. Put your bracket, don't forget your bracket. Plus 12.3. So we'll replace t equal to 3a. Okay, so what happened? Put it in here. So it's going to be 21.55 minus 2a, and then minus again, minus 2a minus 12.3 equal to 3a. So we want to get the value of a. What happened? This is going to go over. 3a plus 2a equal to 5a. So 3a plus 2a equal to 5a equal to 21.55 minus 12 is going to be, okay, 21.55 minus 12.3. Okay, so now this is going to be 25 and then, okay, 21 minus 12, 9.25. Okay, so 9.25. So this is going to give us what? 9.25. 9.25. So we're going to divide by 5, this is this constant. So our acceleration equal to 1.85. 1.85. So our acceleration, that both, because they were tied together, of this object will be 1.85 meter per second negative 2. Or you can say same thing, 1.85. You can say meter over second squared. Okay, so we have acceleration. So let me ask, okay, what is tension? It's easier to get tension because what I'm going to do, I'll take my acceleration and substitute here in the equation which I made the tension the subject. So I'm going to say my tension equal to 2, because they only ask for acceleration for this case, but sometimes they ask for tension. So I'm going to say, take the acceleration, plug it in here. Acceleration equal to 1.85 plus 12.3. Excuse me guys, I apologize. So our tension equal to, okay, so if you multiply this, it's going to be 2 times 5 equal to 10. We catch 1 in the head, bring 1, Grade 3, right? 2 times 6, 2 times 8, 16. And that one, 17. Alright, 7. And now go with 1. 2 times 1, 2. And that one is going to be 3. Plus 12.3. Now we add together. You know what I'm saying? Now, 0. Okay, let's add here. 3.7. 12.30. Let's add here. Okay, this is going to be 0, 10. Right, 0 we go with 1. 5 and 1 equal to 6. Okay, 1. So 16. So tension equal to 16.00 Newton, because tension is the force. So tension equal to 16 Newton. If they ask to say tension equal to 16 Newton and acceleration, we had it already, equal to 1.85. 1.85 what? Meter per second, and easy, man. Now let's go to the next question. Do you have another question or we done? Oh yeah, there's a question. They say, if a block P has passed point B, mean this block P here, see this block P, it comes in and passes at point B. So we see here is very rough. So if you know how it's going to be moving, it's going to move what? Slow, because the net force is very small. But the moment it passes this rough space, a rough area, means now it's going to go quicker. You know why? Because there is no, it's a frictionless surface. So now according to the question here, they say how will the acceleration compare to that of question 2, 3? Okay, so this acceleration, I'll approach guys. So acceleration we had is what is 1.85. So they want to find out like what are the new acceleration after this object passes at this rough place. Oh, the acceleration now is going to be more bigger. You know why it's going to be more bigger? Because this surface here is a frictionless surface. Or in other way, you can say the net force is going to be very big. You know, because the bigger the net force from Newton's second law, the bigger or the higher the acceleration. So the object will increase. The acceleration is going to increase. Why? Because object is going to enter a frictionless surface. You know what I'm saying? So the acceleration will increase. Will increase. Why? Because frictionless surface, the first one. The second one, you could say because the net force is bigger or is higher net force or bigger net force. Okay, there are no friction. Yes, the surface is smooth. Or you can say no friction, the surface is smooth. No friction or frictionless, or you can say surface is smooth. That's all, man. Thanks. It's just a waste of time. You do this question, and it's easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If first time, make sure you subscribe, and you know you can just go and do donation to our Patreon page. I have a Patreon. I have a GoFundMe. You know what I'm saying? I have all the means of donation because to make this project going, you know. Any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace and love. Bye. You know, this is one of my students of knowledge. You know. She wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is story
Yeah.
about the Salesians primary schools.
Yeah, China Bantu. China Bantu's everywhere, right? So this is my other son. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Bantu's everywhere, man.
China Bantu.
Uh-huh.
China Bantu everywhere.
Everywhere.
China Bantu.
Exactly. Thanks a lot, man. Appreciate it. Thanks so much.
If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You like just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Abunga